And now back to you, Professor Hardin.
Well, I may surprise you, but I'm going to say a few words in favor of faith. But you'll see a very special circumstance. Lucretius, again, we're back to the 1st century before Christ. Lucretius wrote a poem on the nature of things in which, with great logical ability, he deduced the existence really of the molecular world, that these solid things weren't really solid. They were made up of little individual particles that could move separately. He called them atoms. The word has changed over the centuries. What he called atoms, we call molecules now. And that was as far as this idea of molecular theory of matter got, as far as Lucretius carried it then, until the 19th century, when the theory of molecules and molecular theory of matter was developed to a great extent. And the important thing is, how did it get developed? What do I mean developed? Well, see, what people would be saying would be, say, like, show me God, show me a molecule. You couldn't show him a molecule. How can you believe in molecules when nobody's ever seen one? Difficult point. In 1821, a botanist named Robert Brown reported that if you look through a microscope at a plant cell, at the cytoplasm that moves around, look, if you have enough magnification, you see that individual particles in the cytoplasm are constantly vibrating, constantly. They never give up, never. It's as though there were no friction. This is ridiculous. There's friction every place you look in the world, but there's no friction there. And this sort of shook people up, but mostly just biologists, because there was a lot of separation of the sciences. And it wasn't until the last of the century that people began to see what the significance of this, and the significance is that these things that you see are being bombarded by molecules. And in fact, one of the three great papers that Einstein wrote in 1905 was on the Brownian motion. This was an absolutely important thing. And shortly after that, a few decades, we began to see things that we could say were, one thing I can't see is, what does that number say on there? See, there's light here, you have to work out something else.
5 minutes.
5, not 50. Okay, all right. I'll make it brief. All right. So that was a shaking thing that really convinced many physicists who hadn't been convinced before when they saw molecular motion. Said, "Oh, that really looks convincing." And in this century, finally, we saw things that we could prove were molecules moving. And before then, we had taken it on faith. Now, there's an example of something that's taken on faith. But the point was, it wasn't just taken a broadside on faith. The physicists worked out the conclusions, what must be true of these molecules if they are moving the way you say. And they had that all worked out well in advance of actually seeing it. So verifying it was sort of an anticlimax. Well, that's the only sense in which faith is used in science. New things that come along often have a great many rough edges, and we do take them on faith for a while. But the idea is someday they've got to prove themselves. They've got to get out of this shadow of faith. Otherwise, we won't take them.
Thank you, Professor Hardin.